Hey Jane.
Hi, Mike. I heard you got a B plus on your math quiz.
Yeah, and I got a surprise after I told my parents about it.
What was the surprise?
A chocolate bar! How awesome is that? Would you like to have some of it?
This is very kind of you, but only if I get an equal half of that chocolate bar.
Wait a minute! Just wait a minute! What is Jane talking about? An equal half? This is nonsense! Absolute nonsense! This is total injustice! Say hello to Mr. Know-it-all, everyone. He thinks he knows everything. Alright, everyone, we need to help Mr. Know-it-all to understand what an equal half means. We are going to do this by using Mike's chocolate that has 12 pieces in a bar and the chocolate schematic. First, we are going to start our journey with a simple outline of Mike's chocolate bar. As you're noticing, I have taken the outline shape of the chocolate bar and disregarded the pieces inside. This is because I'm viewing the chocolate as a whole. So the first question is, how many chocolate bar outlines do you see? Well, the answer should be 1. This is because you only have one outline of a chocolate, nothing more. The outline again is represented here by a shaded rectangle. So we write 1 here to represent what we have. Now, would you like to know something interesting? A secret. Well, what if I told you that any whole number like 0, 1, 2, 3, 4, 5, and so on has an imaginary number of 1 underneath it? But now, having that number 1 underneath it, we are representing Mike's chocolate bar in a fraction notation. Though we still have 1 chocolate no matter how we represent it. Once we get into fraction notation, each number represents something special. For instance, that imaginary number that we added represents how many pieces we have in that rectangle. And pay attention here because we ignored the smaller pieces in the beginning to just represent an outline of the chocolate. Now, if we had pieces in there, the number would have been different. And don't worry, I'll get to it more in just a minute. For now, the rectangle is made out of 1 piece, and that 1 piece is represented by the bottom number, which is called a denominator. Just like the bottom number, the top one must have a duty too. Its duty is to represent how many pieces are left behind or taken from the overall pieces that make up the whole. In this instance, we have 1 shaded rectangle that is made out of 1 rectangle which is present, and we call this representative number the numerator. Now, it is time to get realistic, to look at the chocolate and show Mr. Know-it-all what we mean. Come on, it would be a good practice for ourselves too. First, we will look at the denominator and then the numerator as we go on. Can you do the math and let Mr. Know-it-all know what the denominator is? Psst, this is the total pieces you have in a whole. It is 12! Right on! Because the chocolate is made out of 12 smaller pieces. Now do the same and figure out the number of present pieces. Of course, that is the numerator. Right on! The chocolate is made of 12 pieces, out of which you still have all the 12 pieces. So, now we got 12 over 12. It can also be written as 1 over 1, because A, we can divide the top and the bottom by 12, and B, it is the same as having 1 chocolate bar, hence 1 over 1. Now, you can simplify it furthermore. That is to make it easier for your eyes to see. Since the denominator is 1, and 1 is an imaginary number when placed in the denominator, we can just ignore the denominator. So far, we have looked at an outline and we got 1 over 1, which tells us that we have one whole outline. Now, we can make an accurate drawing of the chocolate bar that is divided into 12 equal pieces, to which we got 12 over 12. And these two equal to one another because at the end of the day, you still have one chocolate bar. This is an example of equivalent fractions. Now that we have understood how to represent the chocolate bar in a fraction notation, how can we divide it in such a way that Jane gets an equal half of the chocolate? All we need to do is look at the numerator and divide the total pieces present by 2 for Mike and Jane. This is easy because each piece in the chocolate bar has already been created to be equal in size and mass to other pieces. It seems like by moving 6 pieces to one side and another to the other side, we have created 2 equal halves of the chocolate bar. But we always need to double check our work. Sure, by looking at it, it is obvious. But it is always good to get into the habit of checking your work. How? Well, you just need to add the 2 halves together to get the original number, which is 1. One chocolate bar. Now that we have set them up in an equation in which we are adding them up, I'm just going to use faded pieces to represent what is missing from the whole, or the original chocolate bar. This will make it easier when we add them up. Now, we need to write a fraction notation for each outline. For instance, the first one is 6/12. 6 over 12 because you have 6 pieces from the original 12 pieces that made up the whole. Now do the same for the rest of the outline shown here. Yes, keep going. You could do this. Now, we need to add 6 over 12 and 6 over 12 together. Pay attention to the numbers now. Every time you have the same denominator for 2 of anything, you can just use the same denominator to add the 2 fractions. Just simply write down 12 as the denominator and add up the numerators. In this case, 12 would be our denominator and you are adding 6 plus 6 on the top. Have you seen this number before? 12 over 12. Congratulations! You have now proven your work that if you add them up, you have one chocolate bar by either representing it by 12 over 12 or 1 over 1 after you have simplified it. Remember, one meaning of a fraction is to tell us how much of a thing we have out of a whole or out of a set. There are also other meanings such as ratio and division. I think I'm getting the hang of this. Not much of a nonsense after all. Now, let's use a balance to show Mr. Know-it-all what we mean by an equal share without dealing too much with numbers. If we put the whole chocolate bar to one side, what would you think would happen? One side would dip completely and the other would go up. The reality is that this is not a balanced picture. To be balanced, both sides need to stay at the same height as the other. But over here you could see 12 over 12 cannot equal or balance out something that is nothing out of 12 pieces. Now, what about this scenario? Is this a balanced scenario? Yes, your scale's plates are staying at the same height to one another. So, according to the scale, it is balanced. We can even use numbers to show this, where 6 over 12 on one side is equal in mass to the other half, which is represented by 6 over 12, or 6/12. The end result of a division is all about having equality, whether that is in size or mass. Now, let's finally do this so they both can enjoy that chocolate bar in equal shares. So there you have it. Finally, they were able to divide that chocolate equally within themselves. What a beautiful ending. That sure was fun.
Mike, wait till I get an A plus and we have to do this for the whole class.